Today we will look at solutions to linear equations in one variable. The solution to an equation is the value of the variable that makes the equation a true statement. Equations in one variable may have one single solution, an infinite number of solutions, or no solution at all. If there is only one solution, then there is only one possible value that will make the equation true. Your answer will be one number. This means that the equation will sometimes be true. A conditional statement is true for some values of x. In this case, it is only true one time. For example, in the case of the equation 4x plus 6 equals 18, you can subtract 6 from both sides and you'll be left with 4x is equal to 12. You can then divide both sides by 4 to get x equals 3. In this case, 3 is the only number that makes the equation true. You can identify when an equation has a single solution because the end result still has both a variable and a number. Now let's look at the case where an equation has infinite solutions. In this case, any value will make the equation true. So your answer can be any number whatsoever. It can be a whole number, a fraction, a decimal. It doesn't matter. The equation will always be true. An identity is always true for any value of x. It is true every time. If you look at the example of 5x plus 15 is equal to 5x plus 15, you will notice that you have 5x on both sides. So when you move one x over to the other side, it becomes a minus 5x. And in that case, 5x minus 5x is just 0. So you're left with 15 equals 15. Since this is a true statement, then any number for x will make the equation true. You can tell that you will have infinite number of solutions because the variables cancel each other out and both sides of the equation look equal. Finally, let's look at the situation in which there is no solution. That means that no value will make the equation true. There is no number that you can substitute for x to make this equation true. In this case, the equation is never true. A contradiction is never true for any value of x. It is not ever true. Let's look at the example 4x plus 8 equals 4x plus 3. When we move this 4x over, it becomes a negative 4x, and a positive 4x and a negative 4x cancel out. So we are left with 8 is equal to 3. This is a false statement. It is never true. So there is no number for x that will make the equation true. You can tell that you will have no solution because the variables cancel each other out and both sides of the equation do not look equal. Now we will practice determining the types of solutions. Let's look at the first simplified solution. 3x minus 5 is equal to 7x plus 3. Notice that the variable terms are different. That is why we say there's only one solution. Now let's look at the second simplified equation. In this case, we have 2 plus 4x is equal to 4x plus 2. Notice that both sides have the same variable. They're both 4x. Also notice that the constant is also the same. They're both 2. Therefore, both sides are equal. Finally, let's look at the situation in which there is no solution. In this case, we have 8x plus 9 is equal to 8x minus 5. Notice how we have 8x on both sides of the equation. Therefore, the variable terms are the same. If you look at the constants, we have 9 on one side and negative 5 on the other. Therefore, both sides are not equal. Now let's look at example 1. In this case, we have 2 times the quantity 4x plus 5 is equal to 5 times the quantity 2x plus 4. Let's go ahead and simplify both sides of the equation. Since we have the parentheses, let's do the distributive property first. 2 times 4x is 8x. 2 times 5 is 10. And then on the other side, we have 5 times 2x, which is 10x, and 5 times 4, which is 20. Since the variable terms are different, the equation can be solved. So let's do that. We'll start by moving all of our variables to one side and our constants to the other. When we do this, we have to remember to change the sign of the term we move. So we now have 8x minus 10x is equal to 20 minus 10. Let's subtract, and we'll be left with negative 2x on the left and positive 10 on the right. If we divide both sides by a negative 2, we will get x is equal to negative 5. Therefore, the equation only has one solution. That solution is negative 5. This solution means that negative 5 is the only value for x that will make the equation true. Now, let's look at example 2. Once again, we are going to simplify both sides of the equation. In this case, we once again have parentheses, so we're going to take care of those first using the distributive property. 2 times 5x gives us 10x. 2 times 4 gives us 8. We're going to leave the stuff outside of parentheses alone, so we have negative 11 equals 4x plus, and then once again we have parentheses. So 3 times 2x is 6x, and 3 times negative 1 is negative 3. Notice how on both sides of this equation we have terms that have the same variable. So we're going to combine like terms next. 10x is the only x term, and then 8 minus 11 is negative 3. And on the other side, 4x plus 6x gives us 10x, and minus 3 is the only constant. Notice how the variable terms are the same. They're both 10x. We also notice that the constants are both minus 3. So both sides are equal and the equation is always true. This equation has infinitely many solutions. This type of solution means that any value for x will make the equation true. Now, let's look at example 3. Once again, we are going to start by simplifying both sides of the equation. Using the distributive property, we get negative 4x plus 15x plus 18 is equal to 14x plus 7 minus 3x. We then look at combining like terms. Here we have a negative 4x and a positive 15x, which gives us a positive 11x, and we keep the plus 18. On the other side, a positive 14x and a negative 3x gives us a positive 11x, and we leave the plus 7. Notice how the variable terms are the same, but both sides are not equal because the constant term is different. This means that the equation is always false. This equation has no solution. This solution means that no value for x will make the equation true.